All right, 8.3, logarithmic functions as inverses. So first off, we talk about logarithms. What is a logarithm? Well, we say if b is not 1, b is positive, y is positive, and y equals b to the x, then log base b of y is equal to x. Now that might just seem like some nonsense, but there's some interesting things that we can do with that. Now, with this, you're going to have to change between exponential, which is this one, that's exponential, and log, which is the second one with a log in it. Logs are kind of like fancy exponents, right? Because we got rid of the exponent. We could call it the inverse of an exponent. We could call it all kinds of things. But the big thing that we need to remember is that y equals b to the x is log base b. It's like a little subscript. It's like the opposite of an exponent. It's like kind of below. Log base b of y equals x. The way that I have always visualized this or kind of memorized it is I think about the log, the thing on the right here, and I always picture that this b comes over and it kicks the x into the exponent. And then we get y equals b to the x. It like kicks it into the exponent. I don't know why I thought of that, but that's kind of the way that I've always thought of it. It slides over and it kicks it into the exponent. So, change of base formula. And we don't necessarily need this for any math that we're going to do in this section. But if you have a cheaper calculator, if you have the regular, like, what is this called? TI-30X2S, you're going to probably need this. So if we have log base A of B, so log base A, actually, you know what? Let me write this differently. Log base, let me write that as log base B of A, base B of A. Log base B of A is equal to the log base X of A over the log base X of B. So this is the general formula here. And again, this doesn't necessarily make a whole lot of sense, but it's going to be important later on. But we could also substitute an X for 10. And the logs that our cheaper calculators will do will only be base 10. So sometimes if you have something like, if you're going to type in your calculator log base 6 of 10, or we'll do something different than that. We'll do like 30, log base 6 of 30. Well, you try to type that in your calculator, it won't work. But what you can do is you can say, well, this is B, this is A, this is all equal to log base 10 of 30 over log base 10 of 6. Okay, this over here you can type in your calculator, but you couldn't type this in. Now, graphing calculators, you normally can type that in, and I'll talk about where to find that in a second, but the change of base formula is just something that you should know. If you have any more, you want to watch more of that, go on YouTube and search that. There's all kinds of videos about that. So, number one, write 25 equals 5 squared in log form. Well, we know that 25 does equal 5 squared, right? So starting off, using our formula up here, where is it? We're going to be looking at these two, right? So 25 is y, 5 is b, and x is 2, or I'll say 2 is x. All right, I'm just looking at this formula up here, and I'm writing in what they are. Now I'm going to use these to write in what it would be in log form. So it's log base b of y equals x. So this is going to be log base b, which is 5, of y, which is 25, equals x, which is 2. And this is our answer. All right, so we can change from exponential form to logarithmic form. Now, in a similar way, we're going to change from log form to exponential form. Now, I think these are just a little bit easier to visualize. I think about the 2 coming over here and bumping the 5 into the exponent. So we're going to say, well, 32 equals 2 to the 5th. And there it is. That is our exponential form. All right, moving on. Number 3, evaluate log base 8 of 16. Now, if you're using a graphing calculator, a Texas Instrument graphing calculator, at least if it's similar to mine, if I press the math button and then I go to the very bottom of the list, it says log base, and I can click on that, and then I can fill in the 8 and the 16, and I get 1.3333, 1.3 repeating. Okay, that's just if I type it straight in my graphing calculator. It'll work like that. I'm sure there's calculators online that you could find that would do that as well. I know that I was able to get Desmos to do that for me. Now, if you don't have a grapher, or if you have a cheaper calculator next to you and you want to use it, what we're going to want to do is want to change this into log base 10. And log base 10 on our calculator, at least on the TI-30, is on the left side. It's underneath the second button. It's in the upper left corner. So I'm going to write that in base 10 for us, just in case you're using a different kind of calculator. So I'm going to use the formula log base b of a equals log base 10 of a over log base 10 of b. So this I could substitute in, and I could say, well, this is going to be equal to log base 10 of 16 over log base 10 of 8. And whenever I type that in my calculator, I'm going to type in log and then 16, and make sure you close the parentheses there. At least on the TI-30 you have to. Then I'm going to divide by log of 8. And I again got 1.3 repeating. So I'll circle this just so that we know that that is our answer. Now, so you probably already see that because that type of calculator, the cheaper calculators, do log base 10, there might be something special about log base 10. And there is. A common log is a log with a base of 10. Something special about common logs is that you don't have to write in the base, right? So if you just have log of y, what that means is that means a log base 10 of y, all right? So that's just a factoid. That's something that we need to know. Moving on, number 4, and there will be some problems like this on your homework. The pH of lemon juice is 2.3. Find the concentration of H positive, which I believe is hydrogen ions. And then it tells you that the pH is the negative log, and what kind of log is that? What base is that? That's log base 10. The pH is negative log base 10 of the number of hydrogen ions. So I'm going to try to solve. I'll say, well, 2.3, I'm plugging in the pH, is going to be negative log, I'm going to put a 10 there, of H positive. Now, I need to get rid of my negative there, so I'm going to just multiply everything by a negative. It puts it over here on the left, 2.3 equals log base 10 of H positive. Now I'm going to transfer into exponential form. So this base here, the 10, is going to come over into there. So here, let me just write the formula down so that we can see it here. We have x equals log base b of y, and also y equals b to the x. So our y is what is inside the log, so we're going to have H positive equals b, which is our base, 10, to the x, which is our exponent, negative 2.3. And whenever we type that into our calculator, I'm going to type in 10 caret negative 2.3. I get some really small number. I'll say 0.00501. And that's going to be our answer. All right. There is a problem on your homework that is very similar to this. Next up, logarithmic functions, the inverse of an exponential. Right? A logarithmic function is the inverse of an exponential. So, let me erase this here. If we start off with y equals b to the x, that's right here, and y equals log base b of x, which is just our normal general equations that we've been messing with so far. If we change the log back into exponential, the b would come over here and the y would go to the exponent. So it'd be to the y equals x. Now I'm going to rewrite this like what I had written first, x equals b to the y. Now the reason that I'm doing this is to show you that this is y equals b to the x, and this is x equals b to the y. If we were to swap the variables there, they'd be equal. So it still follows our inverse rule that we used in last chapter, where we'd swap the variables and then solve for y. That still works here. That shows us algebraically that the inverse of a log is an exponent. Moving on. Logarithmic function transformations. So we have that general form, the y equals log base b of x, that we've been messing with. But if we want to think more about changes to that function, the way that it changes whenever it is graphed, we can think about that. So starting off the a, that's hanging out in front of the log, that decides how much it's stretched or shrunk. And we talked a little bit in class about how with an exponent, with an exponential, like y equals a b to the x, the stretching and shrinking is kind of technically going with the a, but a and b both decide how fast it goes up and down. So again, a and b in our log both kind of play a part in what you would think of as stretching and shrinking, right? The big idea here is whenever a is positive, or excuse me, whenever a is more than 1, bigger than 1, whenever the absolute value of a is bigger than 1, it's a stretch, so it will get taller. Whenever it's less than 1, it will get shorter. It'll get closer to that axis. Whenever a is negative, whenever there's a negative out front, it's reflected. H, just like always, just like we've always seen before, H shifts it left and right, and K shifts it up and down, right? This is the same kind of layout that's used for exponentials, the same kind of layout that's used for quadratics. Now, while I think it's good to know these things, and I think it's good to be able to see how they transform, I'm not going to ask you to graph logs by hand. I will always make sure that you have a graphing calculator for any kind of tests or things, or that you have an app on your phone that you're able to use on homework and things like that. Moving on. Number 5, graph y equals log, and that's going to be base 10 of x, and log base 6 of x. And what we're going to do here is we're just going to look at it in a on a Desmos here. Actually, am I able to open this to the full screen? Well, I want it on the full screen. There we go. All right, so we have the green one is log base 10 of x, and the purple one is log base 6 of x. Oops. So if we look here, there's some different things that we can think about. Which one was it? Green is 10. The green one gets closer to 0, 0, which is kind of interesting. They both cross at 1, and we don't see anywhere else that they cross, right? There would be this little dot down here on the axis if they crossed. So we're not seeing anywhere else that they cross, except for 1, 1, which is kind of interesting. Now, when you're working on your homework, right? Yeah, whenever you're working on the homework, just do rough sketches, right? So what I would expect you to do something from here, and I'm just doing this from memory from what was on the other page. we had, they both crossed at 1, 1, right? So we'd have one like this, and I'm going to check that back here. The purple one started below and it went above, and then we had one like something like that. So this one is, we'll say that, and then this one is that, right? I don't expect some pretty graph, I just expect something that shows the general curve of it. So that's that. Make sure that you know probably the most important piece of here is being able to do this piece here. The y equals b to the x versus log base b of y equals x, right? All right, let me know if you have any questions.